We carry a piece of software in our pockets that can write flawless code in seconds, pass the bar exam, and draft 100 emails before you finish your morning coffee. But if this software is so incredibly smart, why hasn't it given us a blueprint for a clean energy source or sketched out a working space drive? Summarizing human knowledge is one thing. Creating something entirely new, something that does not exist yet, requires a completely different kind of thinking. Mimicking what humans have already done looks a lot like intelligence, but there is a massive, quiet gap between sounding smart and actually being able to invent. Imagine a person who has spent their entire life locked inside a massive, windowless library. They have read every single book on the shelves. Because they have read so much, they can write you a highly detailed essay explaining exactly how a bicycle works. But if you handed that person some steel tubes, a wrench, and a welding torch, they would not know where to start. They have never felt gravity pull a heavy frame down, or scraped their knuckles, or experienced the friction of rubber on pavement. Current AI systems are exactly like this isolated reader. They have perfectly mastered the vocabulary used to describe the real world without ever actually living in it. Large language models operate a lot like the autocomplete feature on your phone, scaled up to an enormous size. When you ask a question, the software relies on statistics to guess the next word in the sequence. It calculates the highest probability path through a massive database of human text, matching patterns as it goes. True invention means stepping completely outside the existing data. If you ask a statistical engine to imagine a solution that has never been written down before, the math falls apart. There is no historical pattern to predict from. You simply cannot invent a physical technology and mathematically rearranging words people have already published. Compare that text-crunching software to an ordinary house cat. A cat has never read a single book, yet it understands physical reality flawlessly. When a cat jumps from a counter to the floor, it instinctively calculates its trajectory. It accounts for gravity, predicts the momentum, calculates the friction, all in real time. Scientists call this intuitive grasp of physics a world model. It is an internal mental simulator that tells biological brains exactly how the physical universe works. Right now, even the largest AI systems running on massive supercomputers lack the basic physical intuition of that cat. If we want machines to build the future, they first need this internal simulator. They have to mentally test how a physical object will behave before they try to create it in the real world. Yann LeCun, a pioneering AI scientist, recognized relying entirely on text data was a dead end, so he proposed a completely different approach. This diagram outlines his cognitive architecture, JAPA. Instead of predicting every exact pixel, JAPA predicts high-level, abstract realities. It doesn't waste energy calculating the movement of a single leaf. It focuses on important dynamics, how solid objects interact and move. Because of this, the AI can actually recognize when a physical event is impossible. It stops acting like a fast reflex and starts acting as a deliberate, slow-thinking reasoning system. This specific structure gives machines the exact same predictive common sense that biological brains rely on every day. To make this work, scientists are no longer force-feeding these models the written internet. They are training them on continuous visual data, like video, to directly teach them physics. This chart maps out how that learning process unfolds. By observing the physical world over time, the system naturally develops a baseline understanding of concepts like object permanence, solidity, and gravity. We are teaching machines the hard rules of the universe before they ever learn a single word of human language. Once these systems step out of the windowless library and accurately simulate our physical reality, they will be ready to invent the technologies of tomorrow.